So this project is designed to get that stream narrowed back up and put it in a pattern and a profile and dimensions that will stay stable over time.
It's been said that natural channel design is a very recent idea, but of course if you look at the way natural channels have designed themselves for millennia, it's a very proven method. What's far less proven is the idea that we can, in fact, successfully straighten, armor, and otherwise modify rivers and expect them to perform.
The process of finding the appropriate channel geometry for this degraded reach is to go to a stable reach on the same river or go into an adjacent watershed where we might have a similar stream type, similar soils, similar climate, and use the geometry of that reference reach to design the river so that we are going to move the sediment and the water that's produced in this watershed. Those were some scenes from the Trout River Restoration Project, which ran from 1999 to the year 2001. Hi, I'm Mike Kline. I'm the River Science Coordinator with the Vermont Agency of Natural Resources River Management Program. In this presentation, I'm going to talk about restoring rivers and how the state of Vermont uses a geomorphic-based approach to restoration that strives to achieve river stability with practices that work with the river's natural tendencies and results in a stream channel and floodplain that functions in equilibrium with the flows and sediment produced in the stream's watershed. An important goal of our restoration projects is to find agreement for resolving conflicts between human investments and river dynamics in the most economically and ecologically sustainable manner. Vermont has found itself in an unending and escalating cycle of spending millions of dollars to maintain river channels, repair and rebuild flood-damaged roads and bridges, and protect adjacent land uses from destruction by erosion or flooding, only to see these river management investments fail during the next flood or result in increased damage elsewhere. Our river restoration program recognizes that a significant percentage of Vermont rivers have undergone channelization. Typically, channelized streams are straighter, steeper, wider, and largely devoid of the in-stream and riparian features that maintain natural channel stability and provide a diversity of aquatic and riparian habitats. Channelization practices that were started over 100 years ago to accommodate early settlement, roads, railroads, logging, farms and mills, and other human investments have been periodically maintained through gravel removal, realignment, channel armoring, and post-flood remediation projects. Many channels have incised, eroding downward, losing access to their floodplains, which are essential to maintaining natural channel stability over time. Many miles of rivers have lost access to their floodplains during frequent runoff events, and in some cases even rare events, involving very large discharges, resulting in a tremendous increase in channel adjustment and erosion.
Every watershed, every stream has its history, and in a lot of cases people start out by straightening out a couple of bends to make room for a road or something. And once they straighten out the bends, they find the river doesn't really want to stay within those banks. It starts working on one bank or the other, so people armor. And if they didn't armor both banks to begin with, let's say they armor here, then next thing you know they need to also armor here. Before you know it, the river is shooting through this area even faster than ever because it has less resistance from the banks, and it has no place to go with all that newfound energy than to dig down in the channel bed.
Adjacent to incised and adjusting channels, land uses including agriculture, residential and commercial development, and transportation infrastructure have encroached into the lands previously used by river meanders and floodwater. While some channelization continues today, many straightened and incised reaches are now widening and aggrading, building up with sediment transported from upstream. Recent major storm events have energized these channelized stream systems with inputs of water and sediment, and in so doing have accelerated these physical adjustment processes as new floodplains develop along the rivers.
What the stream does is it tries to get itself back in balance, and it does that by either adjusting its active channel and or adjusting its floodplain. In this particular case, it's trying to become more sinuous. It's trying to meander more, push that bank further out, bring this bank further forward. And by doing that, it increases its length, and that decreases its slope. And that slope decrease means it has less power. That brings it back into balance with the type of material that it can transport down the stream.
The physical adjustment processes, most commonly observed as stream bank erosion, lead to the planform or meander changes that are imperative for the river system to attain a natural balance within its watershed. These adjustments cause property damage that, in many cases, have become increasingly intolerable for current landowners. To avoid the growing conflict between the changing course of Vermont rivers and our land use expectations, the River Management Program, in collaboration with its partners, must, number one, acknowledge these ongoing physical processes and the circumstances leading to their existence today. Number two, understand and be able to articulate the implications and consequences of different conflict management options. And number three, develop the ability to effectively address conflicts with riverine systems through a combination of passive and active geomorphic approaches. In an active geomorphic approach, we restore rivers to a geomorphic state of dynamic equilibrium through an active approach that may include human-constructed meanders, floodplains, and bank stabilization techniques. Typically, the active approach involves the design and construction of a river channel such that dynamic equilibrium is achieved in a relatively short period of time. Buffer revegetation and long-term protection of the river corridor is essential to this alternative. In a passive geomorphic approach, we allow rivers to return to a state of dynamic equilibrium through a passive approach that involves the removal of constraints from a river corridor, thereby allowing the river, utilizing its own energy and watershed inputs, to reestablish its meanders, floodplains, and a self-maintaining equilibrium condition over an extended period of time. Buffer revegetation and long-term protection of a river corridor are also essential to this alternative. Working with these alternatives has been a dramatic change when we simply dredged, bermed, and armored a stream to mitigate flood damage without respect to the physical form and function of its channel and floodplain. Our stream assessments have shown us that these practices have set in motion adjustments that, more often than not, have led to further erosion. The decades that often intervene between major floods give people the misperception that channelization practices actually work. Generations pass and people forget that rivers have been altered multiple times to protect human investments. For the straightened river, it's only a matter of time before a flood drops a very large load of sediment at some point along its course. The wedge of sediment that builds in the channel during the recession of the flood may cause the river to avulse or leave the channel. In this event, the river can erode its banks tens of feet and sometimes create a whole new channel through adjacent lands, often someone's farm field. Success in the long term will primarily be measured by our ability to solve problems at the watershed and river corridor scale, and secondarily how we resolve conflicts at individual erosion sites. From a geomorphic standpoint, this means recognizing that rivers transport and deposit sediment, and that natural stability and balance in the river system will depend on the river's opportunity to build and access floodplain and create depositional features such as point bars, steps, and riffles to evenly distribute its energy and sediment load in a sustainable manner. The River Management Program is working with its partners to focus on the long-term benefits of a geomorphic restoration approach to both property owners and riparian ecosystems. The largest challenge will not be in applying the science to understand the river's slope and planform requirements, but rather how to redefine the relationship of public and private investments with fluvial dynamics in an equitable manner over time within a valley. The larger short-term cost associated with using a geomorphic-based approach, where land conversion may be necessary, become more acceptable and economically justifiable where river channelization projects have failed repeatedly, or in post-flood remediation where major erosion and property damage have occurred. A passive geomorphic river corridor protection approach may be the most desirable alternative due to its lower maintenance cost, but may be dependent upon landowners willing to accept changes in their land use expectations.
You had two high banks coming down and the river stayed right in it. And it would bring all the big boulders down. You can see them all the way up through here. And it'd end up down in the confluence and plugging Castleton River up.
I think in the past we probably would have looked at a river project like this and dealt with the area of concern. In this case, it was down at the confluence where there was sediment that was constantly building up. And we might have just dealt with that specific area because that's where it appeared the problem was occurring. I think because of geomorphic assessment, we've looked at this entire river and we've realized why there was an issue at the confluence and how upstream these issues were contributing. And I think geomorphic assessment is the tool that lets us look at that big picture.
Well, we knew we had to do something different. We didn't have the money to keep coming down and cleaning it out ourselves, so that's why we got involved, seeing if there's any grants or any money out there where we could come in and fix this and maybe do it right. And we started looking how much it was going to cost, and there's no way one landowner is going to be able to put that kind of money up.
My name is Ethan Swift. I'm a watershed planner with the Vermont Department of Environmental Conservation. We've been able to use the geomorphic assessment information and bring it back to communities and apply it on the ground in order to implement high priority river projects.
I think it's everything is going good. Everything takes time, and everybody's got to be patient, neighbors and landowners and everything, and it's ongoing.
A project like this involves an awful lot of different partners, and I think the Conservation District was really excited to be able to be a part of that and bring so many players together to one place to do a great project.
Following the floods of the 1990s, the River Management Program was able to work with landowners and towns and many partners to complete several large geomorphic-based river restoration projects. The Trout River project in Montgomery, Vermont, completed between 1999 and the year 2001, still stands out as a demonstration of how we are trying to pursue river restoration. The Trout River work combines aspects of both an active and passive geomorphic project, including long-term river corridor protection. The following scenes from the Trout River project still offer important insights as to how we approach river restoration.
We're using some fairly innovative types of management techniques. You can see we're using some tree revetments, which actually have been pretty common for quite a few years in Vermont to help stabilize this area. Something that's a little newer and that's actually being used out west a lot are these rock veins. This one on my left here is actually called a J vein. You can see it has a straight section and a little J on the end of it. It helps provide a lot of energy dissipation and maintains a pool here. We've been building up a floodplain point bar type of situation here. There's a lot of revegetation work that's going on. You can see a lot of willow plantings, bioengineering type of applications along a floodplain terrace that we've built along the edge there. All of that area will be ultimately vegetated.
So what we've tried to do is get to the right belt width for the river, which is about, for the trout in this area, about 600 or 700 feet wide. The right meander length, which is about 1,000 feet long. Right width and the depth, and through all the ortho photos and all the stable reaches, the river told us what it needed, what features we're holding. We measured them. I hope you enjoyed seeing parts of our Trout River Restoration project We continue to monitor the project, which has been in place now for over 5 years. While our measurements have shown that by and large, the project's goals have been achieved, some of the specific treatments we applied were not as successful as we would have liked. Monitoring restoration projects is critical if we are to learn from mistakes and apply lessons learned to the design of future projects. The Vermont River Management Program is applying a geomorphic-based approach to river restoration and river corridor protection. We look forward to working with you as a landowner, as a town official, as a watershed volunteer, or as another river manager toward an economically and ecologically sustainable relationship with Vermont rivers.